This is a simple picture of the electrolytic cell, and we have to discuss all the terms which are related with the electrolysis. First of all, you should know that there will be two types of the elements introduced in the electrolysis. One of them will be metals, and the other will be non-metals or group of atoms which will have negative charge, called anions. So metals have the property of losing electrons. Is that right?
Yes.
And after losing electron, the metals uh, are converted into the positively charged ions, called as, what do we call them?
Cations.
Yes, cations. They become cations, and this is happening uh, in the electrolysis, that they lose electrons, metals lose electrons, and they are converted into the positive cations. And on the other hand, the non-metals are those elements which will gain electrons, and they will convert into the negative charge anions. They can gain electrons and convert into negatively charged ions. What they are called? Anions. So basically, this is the first thing which you have to remember. Then we have the ionic compounds in the electrolysis. The ionic compounds are those which are composed of positive ions and the negative ions. There are positive and negative ions in the ionic compound. The positive ion can be metals, or they can be polyatomic ions or complex ions. Also, similarly, the negative ions can be elements, or they can be polyatomic atoms or polyatomic anions. Now, there are compounds such as the property of the ionic compound is also that they can conduct electricity when they are in their two states. What are those states when the ionic compound can conduct electricity?
They are molten.
And what's the other state? And the other state, please.
Honestly, I'm not sure.
Sorry?
I'm not sure of the other state.
Molten state, and the other state is the aqueous state. What is aqueous state?
When dissolved in water.
Yes, dissolved in water. Exactly, dissolved in H2O. Or you can also call it as aqueous solution. It is the aqueous solution of the ionic compound. So in these two states, the ionic compounds can conduct electricity. And basically, what were the charges present in the ionic compounds which were conducting electricity?
What?
Which charges in the ionic compound conduct the electricity when they are molten or aqueous state?
The negative charges.
Only the negative charges?
Or it's both the positive and negative?
Both, yes. Both the positive and the negative charges, or positive and or you can say cations and anions, they both play role in conducting electricity in the molten or aqueous state. So that's the second thing which you need to learn. And then about the covalent compounds. Covalent compounds do not dissociate into their ions when they are in the aqueous solution, or even if they are in their molten state. Say they don't conduct electricity. They don't conduct electricity because they are not split or dissociated into their ions. So for a covalent compound, we will not find the uh, we will not find the property of the conductance of electricity. However, there are few examples in which there can be an example where the electricity can be conducted. One such example is the ammonia. Ammonia is a covalent compound, and when it is dissolved in water, it gives a positive ion, which is ammonium ion, and the other ion is hydroxide ion. It is positively charged ion and it is a negatively charged ion. So these two ions can give the can conduct electricity. Also, the acids, all the strong acids, like for example HCl, the HCl, H2SO4, HNO3, all of these acids when they are in the aqueous form or in their aqueous solution form, they conduct electricity because they can give hydrogen ions, which is the property of the acids, plus their negative ions or the anions, which are group of atoms. So these can conduct electricity. Now now what basically is the electrolysis? Electrolysis is the chemical change caused by the passing an electric current through a compound which is either in molten or in the aqueous solution or in solution form. So when we pass through an electricity through a compound, passing electricity, it is passing electricity through the molten or the aqueous solution of the ionic compound, which result in a chemical change, that is called the electrolysis. The chemical change here, do you know which chemical changes are they referring to?
I'm not sure.
The oxidation and reduction, which means when an electricity is passed through the molten or the aqueous solution of the ionic compound or the aqueous solution of the compound, then as a result of this, if oxidation and reduction occurs, then such process is called electrolysis. So that's the whole picture about the electrolysis. Electrolysis basically done on the electrolytes. Electrolytes are the compounds basically either in the liquid or solution form. Liquid means molten. Liquid here means molten, and solution means aqueous solution. Electrolyte is a compound either in the liquid or in the more like aqueous solution form that undergoes electrolysis, and electrolytes go through the chemical changes, which are the oxidation and reduction, as a result of the passing through electricity through the aqueous solution or the molten state, which means you are basically passing through an electricity through the aqueous or the molten state of the electrolyte, and as a result the chemical changes take place. Is that clear?
Yeah.
Okay. And what are the ways of passing an electric current through the solution? For that purpose you need electrodes. Electrodes are used to pass an electricity into the electrolyte and out of the electrolyte. Electrodes are the rods. They are the solid structures which are in most of the time made up of carbon. It can be carbon in its another form, that is graphite. You know about the graphite, right?
Yes.
So carbon can be used in its graphite form as the composition of the electrode, and they are these carbons or graphite are basically chemically inert. They do not react with the electrolytes present in our solution. Why are they used for the electrolysis? Because they do not react with the electrolytes in our chemical solution. And the next thing is that the electrodes are of two types according to the charges. They are positively charged and they are negatively charged electrodes. Is that clear?
Yes.
The positively charged electrode is called anode and the negatively charged electrode is called cathode. It is positively charged and this one is negatively charged. I am basically developing the whole story of electrolysis. Like from the start we said what is the basic role of the metals and what is the basic role of the non-metals. Then we saw the oxidation and reduction reaction, and after that we saw that how the compounds are split into the ions for the ionic compounds, and as well as some exceptions of the covalent compounds. And then we saw the definition of the electrolysis and the electrodes. Now that's all, that's what we have covered so far. Now here is a real picture of the electrochemical cell. Basically there are two types of the electrochemical cells. One type of the cell is that cell in which the electricity causes chemical reactions, and in the other case the chemical reactions produces electricity. So some cells are working on the first principle and some electrochemical cells are working on the second principle. This cell over here, it is the one which is working on this principle, passing an electricity through the electrolyte which causes chemical reactions. And which chemical reactions are we referring to here?
The oxidation and reduction.
Yes, exactly, which means redox reaction. We are referring to redox reaction here. Now you can see the construction of the electrochemical cell here. The electrochemical cell is based on the battery provided here. We have the electrodes. There are two electrodes. One electrode will be negatively charged, other one will be positively charged. We have this container made up of crucible, and then the electrolyte used here is molten lead to bromide. Lead to bromide means it is PbBr2. PbBr2. Lead bromide is a electrolyte, and this bulb, the purpose of this bulb, what do you expect? What is the purpose of this bulb?
Is it like to make sure that the electricity is going through the reaction happening?
Exactly. It is used to make sure the electricity is going through this whole circuit. It is moving through this whole circuit like this. So, however, you know that in the electrochemical cell, the wires of the battery are connected with the electrodes, but there is no contact between these two electrodes. There is no contact. Currently, or apparently there is no contact between these two electrodes. So how would we know that electricity is going to the bulb after the electricity has transferred into the electrolyte, and then it is moved back to the circuit and it has lighted the bulb, which means we have to see the chemical reaction which is taking place in the electrolytic bath. We call it as electrolytic bath. In this electrolytic bath, the chemical reaction of redox must be taking place. Only then the electricity can be transferred back into the circuit and it should light the bulb. Now we will need to understand the chemical reactions taking place as a result of this electrolysis. Number one is uh, the light bulb. The lights up showing the electrons are flowing through it. The flow of electrons means electricity, right?
Yes.
Flowing electrons means electricity here. That electricity is flowing through the circuit. And then next is there is bubbling around the electrode, the anode, connected to the positive terminal of the power source. As shown, bromine gas is given off. Okay, so the negative electrode must we need to understand this reaction in detail through the other diagram or other equations. Basically, the lead bromide is present in its molten form. I'm going to write the equations here to make it simple for you. This is present in its molten form, which means there is no other compound apart from this compound. When it is converted into molten form, then as a result of electrolysis we get two ions here. One ion will be positively charged and the other one will be negatively charged. Which of these two will give you positive charged ion? Pb, lead. And see, the name is lead 2 bromide, lead 2, which means its charge will be
+2.
Yes, its charge will be +2. And the second ion is negatively charged. In this case, just Br, and what charge is present on it?
-1.
-1. Yes. So here we have got two ions, lead and the bromide. Now we saw that the lead basically loses electron. So yes, it is being done here. That lead is losing the electron and bromide is gaining the electron, but these should be shown separately in their own chemical reactions. We have to show these formation of the ions in this separate chemical reaction, which are the oxidation and reduction reactions. We call this oxidation and reduction reaction as half equation. Half equation of half reaction. Half reaction means either oxidation or reduction. Half reaction means this, and half equation means you have to show that reaction in terms of the chemical equation. So if we say about the lead, then the lead is a metal. The lead has produced the positive ion here as a result of the electrolysis, positive ion. Now these positive charged ion will now gain electrons in the electrolysis, in the reduction process, and it will convert into a metal atom. How is it happening? It is happening in this picture. The the electrodes here. We saw that there were two types of the electrode. The cathode is connected with the negative terminal of the battery. Negative terminal of the battery, and this anode is connected with the positive terminal of the battery. When the negative terminal is connected with the battery, then as a result of this, the electrons are passed into the solution. The negative terminal pushes the electrons into the electrolyte. Now these electrolytes are being basically given to these positively charged lead ions. The electrons here, these are being given by the cathode. Is that clear?
Yes.
And as a result of this provision of the electrons, the lead ions gain the electrons and they are converted into the lead atoms, or you can say lead metal. Now this lead metal starts accumulating uh, on the cathode. On cathode, the lead ions are being produced, and that is now it is being deposited at the bottom of this container. So basically what we saw, I'm going to revise this portion. What we actually saw that as a result of electrolysis, the PbBr2, as a result of electrolysis, this PbBr2 converted into the Pb plus 2 and Br negative ions. Now when these two ions are formed, these are present in this electrolytic, in this electrolyte, you can say in this solution form or the molten form, but currently here we are using the molten form. So this PbBr2 and the the lead ion and the bromide ion, they are present in this liquid portion of this container. They are present here. Are you getting the point?
Yes.
The molten form and the ionic form of the lead bromide is present in this liquid portion. Now out of this liquid portion, the positive ion, which in this case is the lead ion, it will now move towards the cathode. Why it would move towards the cathode? Because cathode is negatively charged and the lead ions are positively charged. That's why the positively charged ions are attracted towards the cathode. On cathode, the battery is supplying the electrons. They are being supplied by battery. So when the lead ions are attracted towards the cathode, they will now gain the electrons from there. PbBr2 will gain the electrons, and they are gaining 2 electrons, not 1. They are gaining 2 electrons because there is 2 plus charge on it. So it will accept all of the electrons which it can. So as a result of gaining the electrons, the reduction reaction occurs and it converts into the metal atoms, which in this case is the lead metal. And since it was in the molten, why is it in the molten form? There, that's a question here. Why is it not in the solid form?
Because when it's molten, the ions are free to move.
Exactly. We use the molten form of the compound, and that was done through this heat supply. This heat is constantly being supplied to the beaker, or you can say the crucible of the electrochemical cell. So that's why the matter which is also produced is in its molten form, not the solid form. So now this part is, I think, clear to you.
Yes.
Now move to the second part. And we knew that the PbBr2 also produces the bromide ions along with the lead-2 ions. Now this negatively charged ion must move towards the positively charged electrode. The positive electrode in this case is anode, because anode is connected with the positive terminal of battery, and it is that point where the electrons are basically lost. The electrons are lost here, they are not gained, they are lost at the anode. So Br negative ions will show oxidation reaction at anode. When they are gone through the oxidation, then as a result of this, Br atom along with the loss of electron is shown there at anode. This is happening at anode oxidation, and this Br atom cannot exist singly. It has to bond with another Br atom which is also present on the anode. It will combine with another Br atom and it will convert into the Br molecule, Br2. This is a Br2 molecule. Now Br2 molecule is also in its liquid form, because we know from our previous knowledge of the halogens that fluorine, chlorine exists in their gaseous form, bromine exists in its liquid form. Is that right?
Yes.
So bromine is present in its liquid form, but because of the supply of the heat here, this supply of heat will convert the Br2 liquid form, it is L here. The liquid form of the bromine will convert into the gaseous form. Why is it not raising? So the Br2 liquid will convert into the Br2 gaseous form, and that's why we see the bubbles of the bromine gas on the anode. There are brown bubbles, that the color of the bromine gas is brownish. So these bubbles are produced because it is being converted into the gaseous form by the heat of the heat supply. Is that clear?
Yes.
Okay. Now you can go through these points again to revise the whole process. There is bubbling around the electrode, the anode connected to the positive terminal of the battery power source, as brown bromine gas is given off. It shows the oxidation of the bromine at the anode. The next is, nothing seems to be happening at the electrode, the cathode connected to the negative terminal of the power source, but afterwards metallic lead is found underneath it. So lead atom is being formed at the cathode and it starts depositing at the bottom of the electrode. Okay. The next is, when you stop heating and the lead bromide solidifies again, everything stops, there is no more bubbling and the bubble goes out. So here we were providing the heat. If we stop the heat supply here, then as a result of stopping the heat, the lead bromide will no more remain in the molten form and it will convert into its solid form. Then the solid ionic compound cannot go through the electrolysis. It cannot go through the electrolysis, so That's the point when electrolysis stops. Is that clear?
Yes.
Okay. So I have explained you the whole of this passage. I have explained the whole of this process. So I can summarize again. The lead bromide go through the electrolysis in its molten form to produce the lead ions and bromide ions. The lead ions are positively charged. They will be attracted towards the negative electrode, which is the cathode. On the cathode, the reduction reaction occurs. This one. This reduction reaction occurs at the cathode by gaining electrons, and the metal lead is produced. That lead is constantly being supplied heat, so the lead produced will be in its molten form underneath the cathode, underneath the electrode of the cathode. And the next part of the ionic compound of the electrolysis is the bromide ion. The bromide ion are negatively charged. They will be attracted towards the positive charge anode, where oxidation will occur and loss of electron will be there. And as a result of this, bromine atoms will be produced. Those bromine atoms will combine with other bromine atoms to make the bromine molecule, because bromine atoms cannot exist individually. And since the heat is constantly supplied, so as a result of this heat supply, the bromine liquid will be converted into the bromine gas, and that's why bubbles of bromine gas will appear on the anode. Is that clear?
Yes.
Okay. So that was all about the lead bromide. The new electrons on the electrode flow back into the power source because electrons are flying in the external circuit. The bulb lights up. Okay, the electrons were going through the electrodes, and they will go back into the battery, and as a result of this, the electricity will keep in the circuit and it will light the bulb. We sometimes talk about ions being discharged at the electrodes. Discharge word used here is applied both for the oxidation and for the reduction. If we say that discharging of the ion at the cathode, then it means discharging. It means the on cathode we have the positively charged ions, and it means it is a reduction. So what I mean to say, and what this book mean to say, that discharging means both reduction and oxidation. If we say discharge at cathode, then you know that at cathode we have the positive ions and they go through the reduction. So discharge would mean reduction of the positive ions. And if we say discharge at anode, then on anode we have the negative ions, so they go through the oxidation. So over here discharge would mean oxidation. Is that clear?
Yes.
All right. Now the next is electrolysis and redox. You will learn more about oxidation and reduction in chapter 14. Okay, and we have already know that oxidation means loss of electron and reduction means gain of electrons. So both oxidation and reduction equations are happening in this case. Then next The next example taken is electrolysis of the sodium chloride, NaCl. NaCl in its molten form. So when NaCl is taken in its molten form and we do its electrolysis, then the two ions produced will be sodium ion and the chloride ions. These ions will be produced. The sodium ion will go towards the cathode, and on cathode we have the reduction reaction, and as a result of this reaction the sodium metal will be produced. It will definitely be in its liquid form. On the other hand, the negative ions or chloride ions, they will be moved towards the anode, which is positively charged electrode, where the oxidation reaction will occur, and the chloride ions will lose electron and they will convert into the chlorine molecule. You can use two molecules of the chloride ion to show the loss of two electrons and a formation of one molecule of the chlorine. That is another way of showing the oxidation in a single step. Is that clear?
Yes.
Okay. However, for the oxidation and reduction reactions, you have to balance the chemical equations in terms of the electron loss and gain. You can see here that there is one electron being lost in there is one electron being gained in reduction, and there are two electrons being lost in this oxidation. So you should balance this equation. How would you balance these two equations?
What do you mean how I balance them?
Balancing the equation in terms of the electrons, like you have to balance these electrons. You have to balance electrons of the reduction with the oxidation. Any clue?
I'm not sure.
It's very simple. There is one electron in the reduction equation. There is one electron, but there are two electrons in the oxidation. Is that so?
Yes.
Then how the electrons will be balanced? Like how many electrons should there be in both equations? There shall be two electrons in each equation, isn't it so?
I don't get it.
We should have two electrons in both the equations so that the electron lost must be equivalent to electron gained. The electron lost must be equivalent to electrons gained. That's the principle, that's the rule of the redox reaction. Electron lost must be equal to electron gain. Is that clear?
Oh, yes.
So the two electrons which are being gained in the reduction reaction, they must be equal to the number of two electrons which are lost in the oxidation reaction. Now tell me, how can we get two electrons in the reduction reaction?
Would there be two Na atoms reacting with the Cl?
Two Na atoms?
Yes.
Okay, yes. But it also means that you are basically multiplying this whole equation with 2. It means multiply the whole equation with 2. Only then you will get 2 atoms. So 2 Na plus 2 electron, and as a result you will get 2 Na atoms. Is that clear?
Yes.
So that's what you have to do. You have to balance the number of the electrons in oxidation and reduction reaction in every case. Mind it, you have to do this in every reactions whenever the electrons are imbalanced, they are not balanced. Now the other example included here is of the aluminum oxide. The aluminum oxide, the electrolysis of the molten aluminum oxide. Aluminum oxide has a formula of Al2O3. Al2O3. When it is when it goes through the electrolysis, then as a result of this, 2 times of aluminium plus 3 ions will be produced, and 3 times of the oxide ions will be produced. That's the electrolysis of the ions. Now the aluminium has plus 3 charge, so it will gain 3 electrons at cathode through the reduction reaction, and the aluminum atom will be produced here. On the other hand, the oxide ion will convert into the oxygen molecule. We have to always make the molecule of the non-metal, so it will convert the oxide ion convert to the oxygen molecule. But since there are uh, 2 negative charges on each atom, so there shall be loss of 4 electrons for 2 times of the oxide ions. We know that for one atom it will lose 2 electron, but if we have 2 times of the oxide ion, then we will also have 4 electrons lost and formation of oxygen molecule. Is that clear?
Yes.
Okay. So all of these examples include the molten states of the ionic compounds for the electrolysis, but there is another condition in which the electrolysis can be done when we take the aqueous form of the ionic compounds. In this case, it becomes a little difficult to expect the products of the chemical reaction because of the introduction of the water molecule along with the ionic compounds, because we are considering the aqueous solutions. Aqueous solution means there will now be water molecules as well along with the ionic compounds. Let's take an example of the electrolysis of the sodium chloride solution. The sodium chloride solution means the sodium chloride is dissolved in the water. Sodium chloride is dissolved in the water, so you will get sodium chloride solution. Is that clear?
Yes.
Now you already know that when we consider the sodium chloride, then as a result of the electrolysis, the sodium chloride will produce 2 ions. One will be the sodium ion and the other one will be chloride ions. I think that's clear. At sodium chloride will split into the sodium ions and chloride ions. Is that clear?
Yes.
But what about the water? How the water is dissociated into its ions through electrolysis? The water has 2 parts, hydrogen ion and the hydroxide ion. There are 2 components in a water molecule. So you will always get hydrogen ions and the hydroxide ions when the water is ionized when electricity is passed through it, or in other words, it means the electrolysis. The electrolysis of H2O, it will give you hydrogen ions plus hydroxide ions. So now we have two positive ions and two negative ions, right?
Yes.
Which two positive ions are there?
The two positive ions are the hydrogen.
Which two positive ions?
What?
I'm saying that they are now two positive ions and two negative ions in this case. Can you tell me which are those two positive ions?
And the H2O.
No. In case of the electrolysis of the sodium chloride solution, there are two positive ions. Can you tell me what are those two positive ions here?
Yes, the two, with the ones there.
One is the sodium ion and the other is the other one is the
Is the hydrogen ion.
yes, the hydrogen ion. These two are the positive ions in this case, and also we have two negative ions. We have chloride ion and the other one is the other one.
It's the hydroxide ion.
Yes, the hydroxide ion. So in this case, they will be quite difficult than molten cases to determine which of these ions will discharge at electrodes. Like you have to check whether the sodium ion will discharge at cathode or the hydrogen ion will discharge at cathode. And similarly, you have to determine whether the chloride ion will discharge at anode or the hydroxide ion will discharge at anode. Now, for this purpose, we take in the use of the reactivities of the cations and the anions. We have to use those values to determine whether which of these ions will be discharged. That is a different topic here, and I will explain this topic in the next class.